Hello everyone. Today I will be looking at how to use an LCD display driver in embedded Rust. I found this really low-cost display on AliExpress and ordered a few. Even though they need only 2 power pins and 2 data lines, the actual protocol to drive them is non-trivial, so I will not attempt to go that low level. Somebody already wrote a display driver for it, so I will show how to find the display driver and how to use it. Let's start. First of all, I'm looking at some package information. What is the display? So I have some resolution information, some various info. The most important one is it's an I2C that requires a clock and a data line beside power. I already knew that. Then it tells me the voltage required. Luckily it supports 3.3 volts, which is what my board provides, so I don't need any converters. And the really interesting part is the integrated circuit that drives it. So it's this SSD 1306. So for me to program this device, I will need to find information about it. One easy way is just search it in Google, and I say SSD 1306 Rust, and I will find the OLED driver. Another option that I have is using cargo. So if I do cargo search, it will tell me this exact same driver, version 070, and all the rest are probably not the same thing. Like you can see, this is a different IC. So for me, in order to use it, I will have to add this particular driver into my TOML file. I'll go back to Sublime, and I am using the starter project that I showed how to build before. The only thing the starter project does is it blinks an LED. So right now, if I go and say cargo run, it will start a blinky program on my device. So if I reset it, it keeps blinking. I also have a display set because I never resetted my previous tests with the program. So what I can do, I can disconnect it and then initialize it so it doesn't seem like it's working. There is no display working right now. Great. Let's get started. So first of all, I would like to see some examples and figure out how to use it. And if I go to the SSD driver, I'll find a folder named examples. And within this examples, I probably just want the simplest one, which would be text. As you can see, it uses various things like embedded graphics. It uses the driver itself and some STM drivers. I have an F0, I don't have an F1, so I'll need to adapt that. I will just copy paste these items and put them in a project because they will probably be similar enough. And now let's keep adjusting. So I don't want panic. I don't want the hardware abstraction layer, but I do want embedded graphics, and I want the driver. The next thing that I will do, I will go into the actual example. I2C for me is different. I will show you how to set it up, and I will copy the text. Perfect. At this point, what I expect is in theory, once I set up everything, I should have a text that displays, and it should display hello world and hello Rust. Obviously, it doesn't have any embedded graphics. It doesn't have SSD 1306. So I need to set up my cargo TOML and add these. The one that I know I need for sure is SSD 1306. And I don't really care about the version right now, so I'll just do star. If I compile right now, I expect some errors. So let's see. Oh, it didn't. Perfect. That's surprising, probably because I didn't save main. I did. Now I have lots of errors. Let's try again. And obviously it doesn't know what I2C is, it doesn't know about fonts, and generally it doesn't know anything about these embedded graphics. If I go back into the example programs, this thing should have some dependencies, so I'll just carry them over from there. If I go to dev dependencies, which says these are the things that you need to compile everything, I will get embedded graphics and see if that solves most of the things. It compiles, and I2C will still fail, but that is fine. I2C is the only thing missing. Excellent. So at this point, I want to figure out how our I2C works. For this, I will do cargo doc open. And I know my goal is to have I2C working. I know I use my hardware abstraction layer, click on it, And it tells me a few things. Like it tells me that inside this I2C hardware abstraction layer, I have a function called I2C1, and this will create my I2C interface. I will have to provide it an I2C structure. I will look at what that is later. And I need to provide the clock and the data pins. And what are clocks and data pins? Well, if I click on the clock data pin, it tells me that various pins can act as a clock. In this case, PB6, 8, and 10. And the same information I get for the data pin tells me 7, 9, and 11 could be data pins. Remember, like in a microcontroller, not all pins are created equal. Secondly, I will want to see what I2C1 is. It tells me it's an abstract structure, so I'll have to find it. And if I look for it, I will see that it's in peripheral access, create peripherals. Clicking on it, it will say, once you have a peripherals, this has lots of fields. One of the fields is exactly what I need, I2C1. This goes together with GPIO. This is where I will get my GPIO A, B, and so on. At this point, I should have all the information that I need to create the I2C interface. Let's go through it. So the first thing I need to do, I need to import. So I will use create. I already do this, so let's add this above. So I do I2C. Great. So I'm using I2C. I need to create I2C1. So what I will say, I need 2 pins for I2C, so I need a tuple. So I will say equals notice how this is exactly the same like I had before when I was creating LED, and I say this is GPIO PC13. Well, in this case, I know that this is GPIO PB6 and 7. So I'll say I will say 6 and 7. And I need to return this as a tuple. This is fair enough. And it will tell me PB6 is unknown. Like GPIO for the LED was on GPIO C, but in this case, remember, I need PB, not PC. And this PB tells me that I will need to go through GPIO B. So let's call this GPIO B. And take the pins from GPIO B. Interestingly, I have a typo, alternate function 1 and alternate function 1. If you are wondering where I got alternate function 1, this is back on when I was looking what pins are. That's a bit of back and forth, so let's say the clock. I'll go in here and it tells me this is PB6, and I should use alternate function 1. So if I go into PB6, I see this is how I change them into various alternate functions. Each alternate function says what you use a pin for. Like you could use it for general input output, or you can use it for I2C, maybe use it for PWM, and so forth. I have I2C pins, so now I have to create this I2C that my display needs. I get a structure for I2C1 from peripherals. I will need to provide the pins. And the rest of the calls are the frequency, let's say 100 kilohertz. And I need to provide the clock configuration. Everything was provided in documentation. So at this point, most of the things are here. I forgot some brackets in the kilohertz. At this point, I should have something that works. Interestingly enough, it will likely fail to compile. Like you can see, I have this error that it doesn't fit. And the reason it doesn't fit is when I compile everything, this is a full graphics library, and in debug, no optimizations are being made. So it will overflow. It doesn't fit in my flash. So I could grab a bigger flash, a bigger chip. But for now, I will just run it in release, because this will optimize things and it will make it smaller. And I guess it's good enough. Let's switch on the camera, and you can see that it shows hello world and hello Rust, which is exactly what I wrote here. Now if I want to test that this really works, say hello 1 2 3 2 3 4, and I expect the display to be updated. 1 2 3 2 3 4. Now let's take it one step further. What I would really want to is realistically to have something that changes. For example, if I have some sort of a sensor, let's say temperature sensor, I would want to display the thing on my display. So say it's 20 degrees Celsius or something. So to test that I can display some sort of a changing value, I would like to have something like this. Let's create some sort of a counter. And then what I would like is on every loop iteration, I would like to increase the counter. Let's start with 0, maybe it's easier. I will say counter is increased by 1. And then this text, rather than me containing a fixed text, how about if I could drop some sort of text in it? Let's say this is not hello world 234. It will be some text. And what is text? Well, text should be a formatted text. Let's say loop counter. That's it. And this is where the fun begins. There is no format. And right now we are in Rust embedded, so we don't have STD library. We need to use something that's just core. Luckily, core does have some of the things for formatting. In particular, the create allocation does have dynamic memory allocation. So when I format the string, I need to allocate a little bit of memory that contains the loop counter, and there's something that keeps changing. And there are two ways of doing that. Either I pre-allocate the buffer and I implement some formatting functions, or as in this case, I will just enable global heap allocation because that seems to be helpful even for embedded Rust. Let's see how to do that. So first of all, I have a format macro, remember from the exclamation mark. So I'll say macro use, and I will say extern create alloc. This hopefully should make the macro exist. But it says string, it doesn't like the string. Let me pass it as a reference. Let's see this. It should still fail to compile because I don't provide allocation handlers and I don't have features, so I have lots of errors. Rather than trying to debug them one by one, let's see how Cortex-M can handle allocations. And for this, I will go into Google and I will say Cortex-M alloc. I had a bit of typos, but that's fine. I still got to where I wanted. So first of all, I know that the examples should show me some way of globally allocating things. It's this. And I also know that the actual cargo Cortex-M allocator that I need to use should be called something like Cortex alloc-cortex.m, which is on top here. So let's do that. I'll go to cargo toml and I will say I need alloc Cortex-M, and I don't really care about the version, but I tested with 0.0 before and I think that's fine. So I'll include it here. And next, I will need to create some sort of a map which is the same like in the example. So if I look in the example, what it has, it tags something as being, this is the global allocator. So whenever Rust needs some RAM, it will use this heap allocator. Let me paste it here. And beside it, this allocator right now starts off as empty, but at startup, I need to fill it up with some values. And the way the example does it is, I want to do it as early as possible, so I'll put it on top. It does it in an anonymous block. I don't think everything is needed, like there is the static. Let me move it a bit on top. And initialization is unsafe because I just dedicating some memory saying this is my whole memory. I forgot to let. Oh, do I have to use static? Sure. And it doesn't know what Cortex M heap is, so let's use it. Let's see if it still complains. I expect it will still complain because I don't have anything to say what happens if you have an error, an allocation error handler. So I will add, and what I wanted to do is to panic when I don't have such an allocator. So let's type it in. This will never return. And I don't have any ideas. I will just like panic means for me just loop infinitely and it will hang. Probably that's fine. Let's say out of memory. It doesn't know what layout is. So I will need to include layout from somewhere. I think it's in Coralloc. And what it tells me is that this is an experimental feature and I cannot use it directly. Luckily, Rust tells me exactly what's wrong. Like it says I need to enable this feature. So let me copy and paste and go to the top and enable it. At this point, I expect build to work and flashing should move a counter. So let's run release. However, if you look closely, I will try to zoom in on the camera. The counter is not displaying that well, and the reason for this is that we don't clear the screen. So I believe the way this works is when pixels are updated, they are just updated and they are turned on but never off. So what I would need to do, I would say that I always start fresh. So I will do display clear. And hopefully this will run and display a counter that actually starts moving. Let's take a look at the camera. The counter does move. I seem to have been missing a space, but I'll update it. So let's go and add the space, which I mistakenly removed. And then the other bit is see how fast this goes. Like we're in a tight loop right now for the LED blink. I used to wait 300 milliseconds. However, if I remove this, one may expect that, hey, this will be run really, really fast. But in reality, it is fast, but not extremely so. And this is because the I2C has only 100 kilohertz right now. So it takes quite a while for the bits to go through and see what things are updated with. Other bits would be, like you saw what happens if I don't clear. So this means if I want to put this text on top, and I'm saying I'm only updating the loop below, well, this obviously won't work because I'm clearing the screen each time. So what the counter will do is I only have the counter. So that's a little bit inconvenient. So each time you have to draw things, you'll have to draw things only incrementally, or maybe find a way to clear smaller bits of the display. And as a final thing is I have everything set up for a compilation to actually work. You can notice here that I am on a nightly build and there are various features that I enabled. So I'll go through an example how to debug when things don't quite compile, because I went through this before. So I will do podman run, and I will run the official Docker.io Rust image, which is a clean compiler, and I will go to code and I will try to do cargo build. Remember that it's a release, so this will take a while. I'll try to speed it up. As you can see, there were errors. So if I just look at them, it will tell me quite helpfully that I don't have my target And it also gives me the command, what should I do in order to add the target. So I'll run it and try again. It will still fail, and it will tell me that, hey, you are not allowed to use this feature on the stable release channel. And how do I fix that? You can go and search about Rust channels. It tells you how to install the nightly channel. I will do that. And I will also want to say that the default channel is nightly. So let's see, this is a command, default nightly. Now if I try to compile, I will get the exact same error because when I switched to the nightly, I did not have the target for my board. So I need to add the target yet again. And now I'll build it. I should not need to build it through the pager because now I expect it to compile. So in summary, if you have problems with memory allocation, things like that, follow what the compiler tells you, and eventually it should be helpful enough to get everything to compile. I hope this was helpful or at least interesting. Have a great day.